Hello and welcome to Deep Dive. Today we are going to talk about a very interesting new development which has been China's fusion research. This is a step closer to clean energy. Imagine an energy source so powerful that could provide almost limitless clean energy, just like the sun. Now what if I told you that we might be inching closer to making this a reality? China has made a new breakthrough in nuclear fusion research. Scientists sustained plasma operations for 1,000 seconds. This achievement brings the world closer to understanding fusion energy. This remarkable feat raises crucial questions. What does it mean for our future? And how soon can fusion energy become a practical power source? Let's explore these aspects. To understand why China's breakthrough matters, we need to know what nuclear fusion is. Fusion is the process that powers the sun and the stars. Nuclear fusion is different from nuclear fission. Fission splits atoms to release energy, while fusion combines two light atomic nuclei. It usually involves deuterium and tritium. This happens under extreme heat and pressure, forming a heavier nucleus. The process releases tremendous amount of energy. Fusion is revolutionary because it does not create long-term radioactive waste like fission. It uses abundant fuel sources such as seawater for deuterium and lithium for tritium, making this a more sustainable process. Additionally, 1 gram of fusion fuel can generate the same energy as burning 8 tons of coal. More importantly, fusion energy does not produce carbon emissions. Therefore, it does not contribute to climate change. With a clear understanding of fusion's potential, let's examine why China's latest achievement is being hailed as a game changer. China's experimental advanced superconducting tokamak is also known as the artificial sun. It has set a new record by sustaining a plasma state of 100 million degrees Celsius for over 1,000 seconds. For comparison, the sun's core is only about 15 million degrees Celsius. This means China's experiment reached temperatures 6 times hotter than the sun. This achievement is a huge step forward in fusion technology. But why? Because sustaining plasma at these temperatures is crucial for generating continuous power. Plasma is a superheated, charged gas. It needs powerful magnetic fields to keep it away from the reactor walls. If it touches the wall, it cools down and the reaction stops. China's success in keeping plasma state for a long time is a big step towards fusion power. China is not the only country working on fusion energy. The United Kingdom's joint European torus produces 12 megawatt of fusion power for 5 seconds, proving that sustained fusion reactions are possible. In United States, the Lawrence Livermore National Laboratory made history by achieving net energy gain from fusion ignition, though it lasted only a fraction of a second. In France, the International Thermonuclear Experimental Reactor is an international project with 35 countries including China. It aims to generate 500 megawatt of fusion power by 2039. This global competition shows the huge potential of fusion energy. Despite these advancements, major challenges remain before the fusion energy becomes a commercially viable reality. Let's take a look at these challenges. One of the biggest challenges is temperature. Fusion reaction requires temperature over 100 million degrees Celsius, which is hotter than the core of the sun. Scientists are still working on materials that can sustain this extreme temperature. Another challenge is the plasma containment. Plasma is highly unstable, and even the smallest disturbance can cause disruptions in the fusion process. Magnetic fields are used to confine the plasma, but keeping it stable for long periods is extremely difficult. The energy efficiency of fusion reactors is also a major issue. Most current fusion experiments require more energy to start the reaction than they actually produce. To make fusion practical, reactors must generate more energy than what they consume. Another concern is material durability. The walls of fusion reactors faced constant bombardment by high energy neutrons, which can weaken and degrade them over time. Scientists are working on self-healing materials to solve this problem. Lastly, tritium supply is a significant hurdle. Tritium, one of the main fuels used in fusion, is scarce and expensive. Researchers need to find a way to generate tritium inside the reactor itself. Tackling these challenges needs strong global teamwork, more investment, and new ideas. It also depends on advanced technology, better economic planning, and smooth logistics. Working together can help find effective solutions and drive progress forward. Many experts think that nuclear fusion can solve the world's energy problem. It offers almost unlimited and carbon-free power. However, fusion might not be ready in time to meet the climate goals for 2030 or 2050. The world urgently needs solutions to reduce carbon emission. Investments in solar, wind, and nuclear fission may continue, and they must continue. At the same time, research on fusion energy should progress. If fusion becomes viable in the second half of this century, it could revolutionize global energy production forever. China's progress in fusion technology is creating geopolitical concerns. The country is building laser-ignited fusion research centers, similar to the USA's National Ignition Facility. This facility could be used for nuclear weapon research by simulating thermonuclear explosions without actually testing it. India has fewer nuclear reactors than China. While China has and operates 55 nuclear reactors, India has only 23. This creates a growing technology gap. To stay competitive globally, India must increase investment in energy and research. In conclusion, I would like to say the road ahead for fusion energy and China's recent fusion breakthrough is a big step forward. However, commercial fusion power is still far away. The process faces scientific, economic, and regulatory challenges. Despite this, the benefits are huge. Fusion energy is clean, it's limitless, and in the next 10-20 years, it will decide the future. It may stay a dream or it may become a reality. If successful, it will change how the world produces energy. It will also reduce fossil fuel dependence. The new era of sustainable power may begin. Until then, we must invest in innovation and practical energy solutions. With this, we end our discussion today. I hope you were able to learn something about fusion energy, and we'll keep bringing more such topics in deep dive. Thank you.